Example number 3 to finish up 6.3. Create a graph and linear equation from a table of values. Question 1, what equation is represented by this table of values? Graph it. So we have x values and y values. We see that this is consistently increasing by 1. So that's consistent, which means this could be linear. This 16 from 13 is an increase of 3. Same here, and same here. So both are consistent on their own, so we know we do have a linear equation involved here. And the y value is going up by 3, so that means that's our magic number. And the other word for our magic number is the coefficient. So we know that y is equal to 3 times x, and then it's going to be plus or minus something. So let's test that. 0 times 3 is 0. So if 0 times 3 is 0, then we're short 13. So I'm guessing that we're going to have to add 13 to that. Let's test it. 1 times 3 is 3, plus 13 is 16. Oh, that works. 2 times 3 is 6. 6 plus 13 is 19. So that one's good. So we've created our formula here. 3 times 3 is 9. Add 13 gets you to 22. So we've got our equation calculated. That's good. But we do still need to graph this. So positive values, positive values. So we're working in the first quadrant again. And so we're going to have our y-axis on this side and the x-axis near the bottom. So let's draw that in. There's a y-axis, and here comes our x-axis. Again, label them. There's our x, there's our y, and now we've got some points to, well, actually no, we need to put some numbers down. So we'll go every third across the bottom. So 1, 2, 3, 4, and 5. On the side, we're going to go up every second line, and we're going to start at 10, and then do 20, 30, and 40. These are just numbers. We don't have a word problem where there's units involved, so we don't have to put units on the axes. We can just go with these numbers, which we've got a negative 10 down there. So we're good like this. So now we need to put the points on. X is 0, y is 13. Well, this is 0, 13 is going to be about there. 1 and 16 is going to be about there. 2 and 19, about there. And then 3 and 22 is going to go somewhere in there. Just like we did last day, we're going to put circles around these to show that there may be some error involved in their location. And then I will draw a line joining them as well. And this looks pretty good as far as hitting the dots goes. So I've got the line drawn, and we have created an equation, so I will label that line as y is equal to 3x plus 13. So we've created the table of values, or from the table of values we've created an equation, and then we have now graphed it. You don't need the graph necessarily to create your equation. You can do it straight from the table of values. Just a little bit of foreshadowing to future grades in math. If you've got your graph, you will actually be able to use it to calculate an equation as well, based on a couple of details on your graph, but you don't need to worry about that this year. So that's question 1. Let's have a look at question 2 then. What equation is represented by this table of values? Graph it. So we've got different variables this time, f and w. F is increasing by 1. Let's see. That's increasing by 1, so that's good. We've identified that as far as that variable goes, this could be a linear equation. This one, negative 0.5, and then negative 4. So that's dropping, so negative 3.5. Let's see if that's consistent. Negative 4 to negative 7.5. Yep, that's also a change of negative 3.5. And it is here as well. So in that case, we know that W is equal to negative 3.5 times F, and then there will probably be a plus or minus on it from there. So let's do some testing. If F is 1, then 1 times negative 3.5 is negative 3.5. But we're looking for negative 0.5. So the difference there is a difference of 3, so we need to add 3. So that's my guess as to what the equation is. Let's test it with the other values in our table. When F is 2, this becomes negative 7. 2 times negative 3.5. Negative 7 plus 3 is negative 4. Oh, that's what we've got, so we're good. Check it again. 3 times negative 3.5 is negative 10.5. Add 3 becomes negative 7.5. Yep, same thing here. And so it's pretty safe to assume that 4 times negative 3.5, which is negative 14, plus 3 is negative 11. Yep, that one works as well. So we've confirmed that this equation is correct. So now we just need to graph this. F is all positive, W is negative. So in this case, we're actually working in quadrant 4. So we're going to have our y-axis on this side, and then the x-axis is going to sit at the top this time. So let's draw that in. And in this case, that is the w-axis. And then we can go here. And that will be our f-axis. So we're going to go every 3 again on this one. So it's 1, 2, 3, 4, and 5. And on this one, we're going to go down by 2s. And in actual fact, that's what these numbers are going to be as well. All right, so now we can plot some points. When F is 1, W is equal to negative 0.5. So that's going to be right about there. When F is 2, W is negative 4. So that should be right there. 3 and negative 7.5 is going to be right there. Oh, I picked a bad scale. So 4 and negative 11, so 9, 10, 11 is going to be about right there. So we've got our points. There's lots of opportunity for error, especially on this point down here because I picked a bad scale. So the circle around there showing the opportunity for error is important, although that's not bad. Draw your line, label it with the equation that we've created. So that's W is equal to negative 3.5 times F plus 3. And there you have it. So from the table of values, we've created our equation, and we've been able to graph the line as well. That concludes 6.3, which concludes chapter 6.